Hey guys, welcome to the new course on Java programming. This is Remy from Do and Learn. So today we are here to learn about Java programming, and this is the first session what we have here. And I hope this session will be really useful to you. So before we jump into Java programming, let's try to understand what is really programming about, and why do we need to program, and how it affects our regular process. So let's try to understand what is a computer program first of all. A computer program is a kind of set of instructions what we give to a computer, which takes a lot of inputs from the user who's trying to program, and in turn, it works on the inputs and some kind of logics which we instruct the computer to do, and finally, it gives us the output. Now, in order to make a computer to do it, we need a lot of memory storage because a computer program works on a memory storage where it can store some temporary values and it tries to take up that values whenever required. With the help of an input, it tries to give the exact output. Now, when we see it in outset, what does a computer do? So, when you see at a computer, it's pretty simple, even though the logic behind these processing units are really complex. Let's try to understand it in a simple manner. Any computer processing system will have a set of inputs, and finally, it has a set of output devices. So, input devices are the things which help us feed in the input. For example, like the mic, what I'm talking now currently gets my voice and feeds into the computer to process. And similarly, the keyboard, what I'm trying to type, again gets the input in the form of keystrokes and it feeds into the computer. Similarly, the monitor, what I'm seeing in my computer, is an output device which shows me kind of output, or it's my screen. And another output device could be your computer speaker, which throws an audio output where you can hear some songs. But ultimately, when we feed in some input to your computer, it works on with some memory unit. So it needs to store something and it needs to do some mathematical operation. And there should be some guy who is controlling the whole operation. So that is your control unit. So on an outset, what you can understand is that a program is a set of instructions or commands given to a computer with the help of an input, and once the program understands your input and the logic behind your instructions, it will definitely give you an output or a result. And in order to make this happen, we need a memory storage. So moving forward, let's take a common example of an ATM. So this is a simple machine which gives us cash, and we can have two different perspectives of this machine. The first perspective, in a normal person's view, what he thinks about an ATM. A person who doesn't know programming, according to him, the input what he gives is a card and the number as well as the password, and the output what he receives is a lot of cash as well as some kind of receipt. He doesn't know about the internal operations, how an ATM works, and what are all the logics behind an ATM and what happens if there is some error and so on. Whereas when you see in the perspective of a programmer, he thinks in a different view or a different perspective. Like according to him, the inputs fed into the computer or the inputs fed into the ATM is totally different from a normal human's perspective. The idea is pretty simple. We are talking about ATM, but there are different perspectives with respect to the users. So the first user is a normal person, whereas the second user is a programmer. The programmer thinks about an ATM with respect to the logics of an ATM or the program that are given into an ATM and what are all the different sort of outputs that are fetched out an ATM. Whereas a normal user's perspective is just to feed in the account number or feed in the card number and finally he gets in cash. So the ultimate goal of programming is to hide certain details from those people who are not supposed to know the details, and also that internally makes the process pretty simpler. So these type of programming languages are really popular nowadays, and Java is one kind of a programming language which insists on this concept of abstraction. So abstraction is nothing else but hiding certain unwanted details from people who doesn't really require the details, so that it creates a lot of confusion. So moving further, these are some of the advantages of programming what we have. In earlier days, we have this mechanical meters which gives us the electricity readings, whereas nowadays we have the smart readers or smart meters. And on one of the other images, what you see, we have a lot of mechanical components connected, different warehouses and everything, but all of them are integrated with the help of computers where a lot of decision making happens. So programs doesn't work only with the help of softwares. All the hardwares that are connected, even contribute to the programming nowadays. And on my left hand side, you can see a car that runs on electricity, as well as the battery gets charged with the help of solar cell. So the amount of charge that is required and the amount of charge that is depleted. So these kind of information has to be given to the person who is driving that car so that he can charge it whenever necessary. And this type of processing requires a lot of complex programs, and that's what we are doing here. Okay. Moving further, let's take a small activity. So before we move further, the activity is like you assume that you undertake the following activities on a daily basis. Arrange this into a list of sensible order and then split this into three different blocks of related activities. What I'm trying to ask you to do is that we have some around nine different activities. Please try to arrange these activities and try to group them and try to give some preference which one we will be doing first and which one we will be doing next and which one will be the last and so on. So let's take a small time like 20 to 25 seconds and think about it. Meanwhile, I'll think about my list of activities which I'll be doing first and the last and the next according to the list given here. Clock is ticking. Okay, so let's see my list. So according to the list, what I have, I'll have three different groups. And the first group, what I do, I just call them as get up. And under that, I have three activities: get out of the bed, and I just get dressed, and finally eat my breakfast. Then I have another category of activities. I call them as go to work. So what I mean by going to work, so I get the car out of my garage and I drive to work and finally park my car in my office. Of course, that's where I do. And the last group is what is called as do your job. So according to this, we have three categories. One is first I want to just find out what my boss wants me to do today, and the second one is pretty much similar thing. And the final one, once I'm done with my job, I just give my feedback to the boss. So this is how I categorize, but this might vary between people. Just keep this in your mind. Maybe this kind of activity will help us to arrange the elements in some kind of order, and that will help us to do our daily activities. So that is one thing. The one of the advantages of this arrangement is that even you can try to customize your work. For example, what I'm trying to say here is, so we have the going to work as one of the activities here, right? And I've arranged it in order. So what we can do is this going to work can be much more improvised in such a way that while I'm driving, I can listen to the local traffic and the weather report in my car, and I can either decide whether to go by bus or by car. So if at all I'm going by bus or by car, I can just drive to work if I'm going by car, or else walk to the bus station and catch the bus. So this activity of going to work can be improvised, but still it has to be arranged in some kind of an order so that I can follow it one after the other so that it leads me to a proper way of execution and it doesn't worry about the previous order. Now let's take another activity. You keep the previous activity in your mind and try to implement this activity. Finally, we try to compare both the activities and get some result out of it. So here the point is my activity is imagine a personal address book with some data stored in it. Let's say we have some friend's name, address, and telephone number. Now what we are supposed to do is list three things that you might do with this address book. And the second objective is that you need to identify someone else who might use this identical address book, but not for the same purpose, like not for storing your friend's name and address, but for some other different purpose. Okay. That's where we will take some 5 to 10 seconds time and think about it. Meanwhile, I'll think about my own version of it. I'll come back to you. Okay, I'm back. So according to me, what I'll do with my address book. So first thing is that I'll try to find out the details of a friend. I can find his phone number. I can add an address to it, or I can delete some existing address. If possible, I'll try to modify the address if some wrong category is defined there. Or the second one, what I can do is I can create a simple software to store the data in the address book and do some operations. And this software can help me to add the address and delete, because each and every time I have to turn my pages and all these stuff, I have to do the writing by my own. But instead of that, what if I create a small software which can keep everything in my memory? So whenever I need to modify certain address, I just put on some button, it gets me the address and it modifies it. That really looks superb. And the third thing is that I've asked you to think about someone else who will be using a similar or identical address book but for some other purpose. In order to answer this, I can create a software. That software can be used by another person, let's say a bank manager. Instead of storing the details of my friends, what if he stores the details of his customers and the loan defaulters or account holders details? The operation remains the same. To try to understand the concept here, the point is that storing a name, it might be a friend's name or it might be a customer name, but ultimately, at the end of the day, it's just a name, and the data is what we are trying to insert into a computer is data, just a series of strings. So the point here is the operation remains the same, but the usage is totally different. In a similar manner, even this address book can be useful for a librarian. He can just put in the details of the people who has borrowed books from his library, and also he can add some books, the name of the books, the ISBN numbers, and also if he wants to modify the details, suppose if a person returns a book and take another book, he can do lot of additions to it and so on. So the point here is the advantage of doing stuff like this activity is that we can create components which are reusable in nature. Now, when we try to compare the first activity with the second activity, what we have seen, the first activity is a structured set of activities. Let's say you start by getting up from the bed and prepare yourself for the work, and finally you do your work stuff and you close down. Now, if any one among these groups get disturbed, obviously that will disturb the next group. So this type of programming where we have structured set of instructions given to a computer, where each and every instruction comes one after the other, and successful completion of one instruction leads to the success of the next instruction. So these type of programming strategies, what we call as procedure or structure oriented programming. So in procedure or structure oriented programming, you have a common place where you store your data and all the other activities are acting on those data. So these activities can be grouped and they can be structured in some order so that they execute one after the other. One advantage of this programming is that it's always structured. You know what will be next and you know where it's going to end. The disadvantage lies in the same strategy. The point here is every component is acting one after the other. So obviously, if one component is disturbed, then that disturbs the whole process. And also, everyone relies on the common data. So the data is not secure anymore. So it's available to everyone. Whereas the second activity, what we did, we analyzed the problem here. So we had some set of data with it. The data is nothing else but name, address, and phone number. And we tried to create a software around the data, or we tried to create a programming environment around the data. The point here is I have a data, I created an environment, whereas that environment can be used by many different people. Like a bank manager can use the same application in a similar fashion, a normal person who is having a friend can use an application as a contact book, and similarly, a librarian can use an application as a library maintenance software. So each and every component here revolves around the data. So those components is what we call it as object, and different objects are connected between each other. And when you take a single object, it has its own functionality and it has its own data. For example, I take an object called as a book. A book has got its own data, like I can have the number of pages of a book, and also the function that is attached to a book is that I can read from a book, I can write to a book, and all these stuff. And then I can have a simple object, like I can call it as a that barcode reader. So the barcode reader can have some kind of a data, like how many, what is the length of the barcode that is being read, and also the function that is done by a barcode reader is that it reads the barcode and it translates the contents of the barcode into its own memory. Now you can have a connectivity between this book and barcode. So the point here is the book's data is secure with the book's object, whereas the barcode's data is secure with the barcode's object. But still, there is a function and there is a system that happens between these two objects. Similarly, you can try to imagine different objects. The objects are nothing else but it's a kind of real-time entity which has got two main properties. One property is that it should have an attached data with it, and also it should have some kind of an functionality with it. everything what we look around us is totally objects. So we can just go on naming it, like the mic what I use here. That's an object. The mic's functionality is that it translates my voice into a digital data that can be fed inside a computer, or it can be given as an analog data to a speaker where you can hear it. And the properties of a mic, or the data respective to a mic, is that I can just say the color of my mic. I can say the noise factor of my mic. I can say, what is the length of my mic wire, and so on. So each and every object has got its own data, and it has got its own functionality. And when we try to connect these objects, obviously we create a system. And this type of programming strategy is what we call as object oriented programming. So being said, in today's session, we just analyzed what is a program as such, and how we do programming. So what is the need for programming? Then we slowly moved on to two activities which explained us what is a structure oriented programming and what is an object oriented programming. So if you have any queries, please do email me, or you can put in the comment box. In your next session, we will start with Java programming. Of course, especially starting with object oriented programming concepts, then we can start with Java programming. So thank you for your time. Stay connected. If you like this video, please do share, like, and comment. And also please do subscribe for the channel for new videos. See you in the next video. Thank you.